Hey guys, once again welcome to my YouTube channel. So in this video we are going to discuss about quite interesting thing, which is how memory in a microcontroller works. So by microcontroller you can consider all sorts of electronic components or equipments around you, like refrigerator, microwave, or even your TV remote that you can see behind me. So your computer has a microprocessor but which works on a motherboard, which is sort of an enlarged microcontroller in a way. To start with, everyone knows that if we are doing something, if we are doing some functionality, we have some steps or some instructions embedded in our brain. So we know that what things we have to start with, or what are the steps to complete the task. Similarly, a microcontroller, which is like small computer, needs to know what instructions it should execute. For that, it needs to store those instructions or those steps somewhere in its memory. That memory is nothing but what you call a microcontroller memory. Now, microcontroller memory can be bifurcated or divided into two types: flash and RAM. So flash is like ROM, and the flash basically means that you can flash some code on it, and which can be uploaded to RAM as and when required by the microcontroller to execute some instructions. RAM memory, there are two types of RAM: SRAM and DRAM. SRAM is sort of a faster RAM which can be used by any of the cores to quickly access and store some variables or some data that it will be needing at regular time intervals or quite frequently. And DRAM is comparatively slower memory. See, DRAM is still faster than flash, but it is slower compared to SRAM. In that, the CPU can store instructions or data which is not that frequently used, or which can be kept in a buffer for occasional use. In that way, a DRAM can be used. Apart from that, there are some other memories in RAM. So considering the memories like cache. So a cache memory is small in size but high in performance memory. This memory is usually based upon SRAM that we discussed some time back. The main memory of microcontroller is based on DRAM, which is comparatively slower, but as we discussed, SRAM is much faster than DRAM and hence it is being used in cache. Now cache is divided into three types: L1 cache, L2 cache and L3 cache. L1 cache is the closest to the cores of the microcontroller. Usually L1 cache lies inside the core itself. So whichever variables or whichever data which microcontroller needs to access frequently can be stored in L1 cache. For instance, let's consider a for loop. In the loop there is a variable called I which needs to be frequently updated, or for every iteration of loop it needs to be updated. In that case, the core will use this L1 cache where it will be storing its variable I, and it can be accessed quickly to update and retrieve the data. Similarly, there is another cache called L2 cache. L2 cache lies outside the core, or it can at times also lie inside the core based on the configuration of the controller. But this L2 cache is comparatively slower than L1 cache. At the same time, it has some benefit, which is it is higher in storage space compared to L1 cache. Third cache is L3 cache. L3 cache is usually a shared memory in multiple cores. So let's consider we have a microcontroller with two cores, core 1 and core 2. L3 cache will be the memory from which the microcontroller can quickly fetch data. Both the cores of the controller can quickly fetch data or store data in it. So basically, L3 cache is like a shared partnership between the two cores. So a quick takeaway from this discussion is that L1, L2 and L3 caches go in decreasing order of performance and speed, but in increasing order of storage space. That's all for this video. I hope you loved this video. Please subscribe my channel and share this video with your nerdy friends, and I'll see you next time.